Good afternoon, ladies and gentlemen. Today, what we're going to do is we're going to talk about something that we should remember, and that is polynomials. So, the topic, your learning target today, the learning target today is I can name, classify, and operate with polynomials. Okay, so that is your main objective today. So what the heck is a polynomial? Let's first talk about monomial. Mono means one, like mononucleosis, mono e mono. So mono is one. So any term, a single term, a variable, a product of variables, or anything like that is a monomial. So what are some examples? Like the number -6, 7x, that's a mono. Most people don't believe this, but 1/2 x squared y is also a mono. Those are all monos. Now, going back to last year or where a previous math course, you probably have remember some of the exponent rules. So I'm going to go pretty quick through them. The product rule. Remember when you had the bases that were the same? Do you remember what you did here? Oh, that's right. You added them. So a plus b. So if I had x to the third and I multiply it by x to the fourth, that's x to the seventh. That's the product rule. Do you remember the power rule? The power rule was something like if I take this guy and I take it to the power, then this is going to be, you multiply the little numbers, right? So if I have x to the third and I'm squaring it, that's going to be x to the sixth. Quotient rule. The quotient rule, if you remember that one's kind of like the product but different. So if I have x to the a divided by x to the b, you subtract them, right? So if I had x to the 4 over x to the 5, this would be x to the -1, which I'll get to in just a second. The negative exponent rule, that was when you had like that means small numbers. So x to the -a, that's 1 over x to the a. So if I have x to the -5, that's 1 over x to the fifth. So negative exponents give you tiny fractions. They do not give you negative answers. They will never do that. Now my other one, the zero exponent rule. X to the 0 is equal to 1. Right? That's anything to the 0 power. So if I took 4x cubed and I took that to the 0, that'd be 1. The only thing that is not cool is when you can't do 0 to the 0 power. That does not equal 1. Okay, so a couple quick examples are right here. So if you take like -6 to the 4 times -1 over 4 squared. Well, first thing I'm going to do, I'm going to punch -6 to the fourth power in my calculator, and I'm going to say, well, -6 to the fourth power is -1296 times, and this will be 1 over 16, right? And then that reduces to -81, right? You see that? Next one, like number 3, you got -3b to the -2 times 8p to the 6. You could do it like this. So -3 times 8 is -24, and these guys have the same base. You're going to add it, p to the fourth power. All right, so that's pretty simple. Looking at a few other ones, like if you look at number 7, all right, number 7, you're going to take everything and you're going to square it, right? You're going to take everything and you're going to square it. So the first thing I'm going to do, though, actually, is I'm going to do this. I'm going to say 39 over 24. 39 over 24 reduces to 13 over 8. And then c to the 7th over c squared, that's going to give me c to the 5th upstairs. And then d4 over d to the 5th is going to give me a d to the 1 downstairs. And then I'm going to square it. So if I square everything, I get 169 and then c to the 10th over 64d squared. So I did 3 of them. There's like 5 more that you can do on your own, and I can give you the answers another time. Let's move on to the next thing. The next thing that we got is polynomials. Poly means many. Polynomials means many. So a polynomial is the sum or difference of many monomials. The highest exponent of the polynomial is the degree. And then what standard form is you're going to write this. Standard form is written in exponents are in descending order. Descending order. So you can classify polynomials by their term, or you can classify them by their degree. A degree of 0, that's a constant. That's like the number 1. 1 degree is linear, second degree is quadratic, third degree is cubic, fourth degree is quartic, like 4 quarts, quartic. Fifth degree is quintic. Anything beyond that is just whatever degree, like it's the sixth degree, the fifth degree, the eighth degree. One term polynomial we said is a monomial, so we already said that, monomial. A two term is a binomial. Three term is a trinomial. And a fourth term and beyond is just a polynomial, if that makes sense. Now, when you add or subtract polynomials, you just do it like you normally would. So like in this case, here's number 9. I'm just going to combine my like terms. So I get 9b squared, and then I get plus 3b minus 18. And since that's 3 terms, that's going to be a quadratic because of degree 2, trinomial. If I look at number 11, what's sneaky about number 11 is you want to distribute that negative through, so you get negative 3y squared plus y cubed minus 2. And then you just distribute that through right there, y cubed minus 4y squared. And then what happens is that all polishes up to 4y cubed minus 7y squared minus y minus 2, and that is actually a cubic polynomial because it has like 4 terms. Now when you multiply, that can be a little bit crazy. So I got a couple ways to show you this. So a couple ways that I'm going to do this is I'm going to actually go off of the sample here and do a couple of them. Like number 13, you got this. You got x minus 3, and then you got 2x squared plus 6x minus 7. Well, how am I going to do that one? I'm going to do this guy by something you may or may not have seen using the rectangle method. So what does that mean? I'm going to put a 2x squared here, a plus 6x here, and a minus 7 here, x minus 3. And then what I'm going to do next is I'm just going to do multiplication. This is 2x cubed. And this is 6x squared because you multiply. This is negative 7x. This is going to be negative 6x squared. This is negative 18x, and that's positive 21. You can see that these guys match up. So you can combine their terms, and when you combine their terms, you get something like 2x cubed plus 6x, because the squareds go away. So, no, sorry, 2x cubed minus 25x, duh, plus 21, and that's a cubic trinomial. Okay, that's a cubic trinomial. Looking at number 15, if you're going to do number 15, you can do that one the same way. You can go 4j minus 7k this way, and then 4j minus 7k this way. And if you do that, and then if you do that, you get 16j squared minus 28jk minus 49k, or excuse me, minus 28jk, and then plus 49k squared. That gets me 16j squared minus 56jk plus 49k squared. That's going to give me a quadratic trinomial, right? Because it's a degree 2. And to close this off, to finish it up, I'll do number 17 because that one's crazy. You got a trinomial by a trinomial. So again, you just do the rectangle method. You just do the rectangle method. You got 3 boxes. So it's going to be 3 boxes by 3 boxes. So you're going to go p squared here, and then you got a positive p here, and then you have a negative 6. And then this one you have a p squared minus 2p plus 1. So this gives me p to the fourth. This is going to give me p cubed. This is going to give me negative 6p squared. This is going to give me negative 2p cubed. This is going to give me negative 2p squared, 12p. And this guy right here is p squared. This guy is p, and this guy is negative 6. You can see that these diagonals all match up. So when you finish it out, you combine your like terms, you get p to the fourth minus p cubed minus 7p squared plus 13p minus 6. That's a quartic polynomial. So that's how simple it is. You go ahead and try the even ones and include that story problem, and we'll talk more about it in class. So that's it. I'll see you in class tomorrow, and may the